The opposite is true then. If these 6 will always be assumed in this course to be strong 100%, then without any other information, you are to assume that every other acid
are weaklings.
are weak. Does that mean every other acid is weak? No, it just means that for this course, for our attempt at learning this material, this attempt called AP Chemistry, that's what's true. Okay? Alright, let's move on to the strong bases. So, let me give you a spoiler. If it has a... And what is hydroxide? OH negative 1. If it has an hydroxide, it is going to be a strong base. But there are a couple that aren't strong, so here is the official list. All group 1A, which includes lithium, sodium, potassium, rubidium, cesium, francium. These elements, and then which 3 other elements, guys? It has OH.
Calcium,
The nice thing,
strontium, and barium.
you guys want to know how Omar, you guys remember Omar, who came in to visit?
Yeah.
You want to know what he coined?
What?
Linac Caserba.
Literally what?
But why though?
Linac Caserba. Linac Caserba. Okay, you know what? It doesn't have to be perfect. He got a 5. That's all that matters.
Wait, so we're not gonna have to worry about RBC?
No. You do have to worry about RBCSFR. It's an imperfect memorization.
Okay.
But you know what's good about that memorization tool? It gets you thinking about the CASRBA, right?
It's like an S.
And then you can try to just remember the RBCSFR. Yes, what's up? Yeah, go ahead.
Wait, Linac-Caserba? That's, okay, so you said possible cations.
Those are what would go in front of the OH minus.
Right, all group 1A cations, so it's Linac-Caserba?
Yeah, it's neglecting the RBCSFR, which also are strong, but they're not as common.
Okay, so, and.
But you do need to know these 3. What's that?
And like beryllium?
No. From group 2, what are the only 3 you gotta know, guys?
Oh.
CASRBA.
Okay,
Come on.
so Linac-Caserba, okay, and RB.
And RBCSFR. And you can just remember, guys, is group 1 really reactive?
Not really.
Yes, it's hugely reactive. It's called the alkaline metals. You put them in water and they blow up.
Oh, not all of them blow up. Just mostly sodium.
All right, go ahead, sir.
So it says a possible cation
It just
in
dies.
group 1A. So would water be a strong base or acid? Or could it just be either?
What?
Water is the definition of
Water
neutral.
is
Water can be the opposite.
Water can be either a acid or base, right?
Correct.
Water can be turned into an acid
Is
or a base.
water if a acid or base? Is it a strong acid or weak acid? Or strong base or weak?
It's just in the middle. It's like
It's-
like the responder.
It's 7. It
All right, yes,
depends.
sir.
So,
believe it.
like, thinking about this from like an acids and bases perspective, right? So if I throw solid sodium, right, into water, into liquid water.
Because it's sodium fine, am I right?
So if I throw solid sodium, right, and then
Okay.
into
It's gonna
water,
blow up.
right, exactly, right?
Oh,
So
it doesn't
the
actually
water-
blow up. It generates a lot of, it separately generates a lot of heat and H.
Yeah, so what the water gives protons to the, is that what happened? Is that happening? Is it the acid, or is the water the acid?
No. It's kind of a separate thing because it makes OH. It separates the water into OH and H plus. Or not H2 gas.
Okay, so it's different, it's a whole different
Yeah.
scenario.
All right, guys, let's take a look here. So yes, we've talked a lot about the OH, but what deserves an honorable mention are all the weak acids containing nitrogen. I'm sorry, bases. I had acids on the tongue. Weak bases containing nitrogen. The lone pair on the nitrogen accepts protons in solution. So guys, those H pluses are kind of lonely, and what are those H pluses from acids attracted to? This lone pair. And guys, N was part of FON, right?
Yeah.
Because N is very electro
Negative.
negative. So that means there's a large amount density of what charge right here?
Negative?
partial negative charge, right? So would the H plus have a big attraction for that lone pair then?
Yes.
And that's why many of your nitrogen compounds can act as bases because they can accept those H pluses. So we've got two examples here. We've got an N with an H and then two CH3s, which can go after water, and the water can act then as a acid.
That's good.
And then we've also got this kind of benzene-like ring with a nitrogen in it, and it can do the same thing against water. Yes, sir. All right. Any questions, guys, about our nitrogen-containing weak bases?
I want to copy the first example down because it looks cool.
Go ahead.
Makes me feel smart when I copy stuff.
You mean the second example?
I don't really understand. I understand the first one. Wait, are they the same thing?
No, this one is like a carbon ring. And remember, guys, what do these lines represent?
Oh, it's like hydrogen or something.
What was that? A something bond?
Double bond.
A double, these are double bonds.
Oh.
Oh, did I talk about you guys how to do organic chem?
Yeah.
With the lines?
Oh my god, like.
I forgot everything.
Let's see.
Yeah, so guys, what's coming off of each of these, but not really?
Carbons.
Well, carbon's at the
Oh,
point.
oh, my bad.
Hydrogens are here, right? Yeah.
I don't get it.
So, Edward, each of these points in this ring is a carbon. And remember, carbon can form how many covalent bonds? So if you look, each one of these points has 1, 2, 3 lines coming out of it, right? So how many bonds does that leave carbon that can it still have? It has one left, and that is assumed to be a hydrogen. So if it's not written, guys, it's a bond to hydrogen. Man, we learned so much in here. All right, anyone still need this slide?
Give me a sec.
I'm back. Yes, sir.
So wait, so nitrogen bases, they're weak, but they're not like super weak.
They're all weaklings.
They're just weak according to our definition, but they're still dangerous.
They're weaklings.
They're scary and dangerous. They're just not.
They're scary, pathetic
I mean,
weaklings.
they are weak.
Read this out with the lab.
Huh? You are not putting any of these intentionally on your skin on my watch.
I mean, like, what if you can't run that fast?
Theoretically.
Theoretically, what if we locked you in that other room?
Forcefully.
Forcefully lock you.
Yeah, tied you up.
Do you have these chemicals in the room right now?
Whoa,
Are they labeled?
Are they
So
labeled,
clear,
perhaps?
guys, rebellion is still illegal. We're not
Listen, no, it isn't.
Can we
Only
unionize?
mutiny.
All right,
And no one would know.
All right,
You didn't
guys.
tell them, would
So you guys already have unionized. It's called Discord. All right. So strength of acids and bases. Strong acids always have very weak conjugate.
Bases.
And guys, you want to know why? Because of equilibrium. It's like it's kind of like a tautology. It's strong because it's strong. If it pushes to the other side, right? It's strong because the other side is unable to.
It's weaker, so
It can't push it back.
So it's relatively like.
So by extension, it's strong because the other side can't push back.
That's bullying.
And actually, guys, I should note to kind of try to avoid some confusion. Your homework does this a lot on this one, especially where it'll say, "Oh, that one's strong because on the other side, its conjugate is very weak." You're gonna see that a lot in the homework. Okay. Oh, I'm still reading.
Oh, okay.
Very weak acids always have very strong conjugate.
Oh, so it's inverse. Oh no, sorry.
And then acids with mid-range strength have conjugate bases with. And the way you can think about this, guys, because it might seem confusing at first, guys, if it's strong, its conjugate must be. And then think of it like a slider. I could go like this. So now, if it's really weak, the conjugate has to be. And then what happens if I get closer to the middle? What happens to both of them?
Even
How
out.
do you know if they're in the middle? Because we only know
The
some.
K value, K values.
Okay, so we're gonna.
K values, guys,
Mr. White, when do we start the math? When do we get to the door?
2.
Like literally next
It's
time.
only today's morning. I want to do math.
Put me in, coach. Put me in. You know, I think that's the reason out of all my bathroom passes, this is the one that has not been lost. When you put it down, it makes that sound that pierces inside, right? And I think that's why it hasn't been lost.
Oh, do you think
What
we're
was
gonna
the
finish
first?
this?
Oh, didn't we have a trophy? As a
No, you guys tried to use the trophy, and I was like, no.
Well, wasn't that the pass during like quarantine?
No, the pass in quarantine was you use your phone to scan the thing.
Well,
Oh,
later stages.
can we bring that back?
I missed that. That was great. All right, yes, sir.
What is the middle value for K? Isn't it one?
No,
No, someone.
oh, no, yeah, like close to 1, yeah.
Okay.
Because that would mean the products and reactants are close to each other.
And then
But it could be anything from 0.1 to like 10,
And equilibrium is one.
like 50-50 would be 1.
Yeah.
Yeah. All right, let's take a look, guys. So, CH4 methane we know is very non-polar. So does it make sense that it's not very strong at all?
Yeah.
Something non-polar shouldn't really be a strong acid, right? But what happens as we add polarity, as we, go up to acid strength? What's happening to our conjugate base strength?
Is this something important to write, or is it just like something you can derive in your mind?
You could probably derive it in your mind. Because we know that this one, and this one are...
Strong.
Actually, I misspoke. Was HF on our big 6 list?
Oh no.
So HF, guys, I just want to throw it out there. HF is a wolf in sheep's clothing. HF looks scary, right? It's got something from the halogens. It's got an H in front of it. You would think that one should be scary, right? But it is not. HF is weak.
Did you mean a sheep in wolf's clothing, not a wolf in sheep's clothing?
No, it is a wolf in sheep's clothing.
Yeah, but like that would mean it would come out and then start eating other actual sheep.
Oh, you're actually right.
Yes, as normal.
Wait, so wait, is HF like still actually dangerous? It's just not strong.
Well, yeah. You leave any sort of thing on your skin long enough. it'll
Why is
irritate.
HF why is HF weaker than HCl? Wouldn't H?
This is a great question,
Oh, wait,
and it's
because
one for
I
which
know-
will be answered.
I know why. Okay.
So, guys,
Whoa.
Wait,
Oh.
do you go?
I'm back.
Brain this. Okay.
Do we have to know that
Strength,
the
we're talking about it being able to dissociate in
Yeah.
water, right?
Yes.
Okay.
Mr. White?
Additional strength.
All right, guys, I'm gonna have to speed up to get this done.
I have a quick question. Do
Yeah.
we have to know? Will we ever have to compare like with the strengths of like one with the other?
Yes, but it'll be with things that are very obvious. Like you should know that HCl is very, very strong.
Yeah.
So then Cl minus would be really, really weak. So then you can make a comparison between this and whatever it's reacting with, like water.
Yeah. Okay.
All right, so let me move on, guys. The stronger base always accepts the most protons in an acid-base reaction. There are always 2 bases. The base on the reactant side of the equation and the conjugate base on the product side. So what you can think of, guys, this is just one way to think about it, is it's a competition between the normal base, the base on the reactants, and the conjugate base. And whichever one is stronger determines which side it goes on. And if it's stronger, it goes to the opposite side. Yes, sir.
So then maybe, right, like thought process, I can look on the acids on each side and be like, hey, this acid's kind of strong, or, and then
Yeah.
which means, like, the other side.
Yeah, long story short, yes. All right, moving on. So, guys, strong acids have weak conjugate bases. So if this HBr attacks this H2O, the H2O and this Br minus are actually going to compete for that H plus. But because H2O is the stronger base, it's going to go like this, like you see. It's not going to cross over. Yes, sir.
If Br is a stronger base, wouldn't it just not react?
No. Oh, yes. Or it would go this way.
But wouldn't the acid also be the stronger acid? Or does that not matter?
You know what? To be honest, it's all kind of like it's true because it's true type of thing. So, guys, main thing you guys need to know is which one of these is on our list. And therefore, if you have to explain it, you just say that you have the knowledge that it's going to go forward because this is strong. But when you're writing it down, you'll say something like this H2O is stronger than the Br, so it accepts the proton. That's why it goes like this. Yes, sir.
Do we know that H2O is stronger than Br because of the whole thingy with the thingies?
No, we know it's stronger because this is one of the big six.
I'm talking about the H2O, right? Like, how do we know it's stronger than Br is?
Because this 100% dissociates, so it has to do this. All right, moving on. So weak acids have strong conjugate bases. So this NH4 plus, when it says strong, again, we don't mean strong. We just mean stronger than this one. So this NH3 is going to be stronger than this one. That's why this doesn't go forward very much. It stays, for the most part, going this way. All right, so what determines the strengths of different acids? Why are some acids stronger than others? We say they want to lose protons, but they don't actually want anything. It has to do with our lovely forces of
Attraction.
between the elements. Okay, so to answer, I forget whose question earlier, the reason HF does not belong with the cool kids crew is because F has a really small atomic, and so the H and the F are actually really,
Close together?
they're tight, they're best buddies. Guys, is it easy to rip best buddies apart?
They're tight, they're down.
It's hard to rip them apart, right? But the whole point, the whole thesis behind acids and bases is what needs to be ripped off.
The H.
The
They
H.
want to
So
dissociate.
these three are big enough that that H freely comes off. Yes, Solomon?
So pretty much, they'll give us like, what was the strongest acid that we had?
H2SO4 is probably among those.
Because it's really big, right?
Plus it's got two H's.
That's
Yes, Marcos?
Why does it have two less than? Doesn't mean it's like a very.
It's like very much weaker than the others, yeah. All right. Okay, go ahead and answer a second. Yes, sir.
So yeah, so because the HI can like, it's so big, right? It's big so that it can give off that H plus ion
Very easily, yeah.
very easily compared to HF, so that's why it's stronger.
All right, guys, moving on here. As far as the conjugate base strength, F minus will be the strongest of the conjugates. And it makes sense because it pushes it back to HF. Okay, that's why HF is the weakest acid. Okay, it's kind of like reverse logic there. All right, so there are two types of oxo acids. And an oxo acid, I'm so glad you asked, an oxo acid is anything where it's an H attached to an O. And oh my God, here we go. Mr. White, you said that if it has OH, it's a base. But that was true when the OH was attached to a metal, like any of these. If the OH is attached to any sort of hydrocarbon, then what's actually going to potentially rip off is not the entire OH, but instead just the H. And guys, what is our statutory definition? If an H plus is coming off, it is known as an acid. So that's how, even if it has an OH on it, it can be considered an acid, specifically an
Oxo acid.
oxo acid. And this Y really should be what letter?
C.
Or a whole bunch of C's, right? This is just like a placeholder for any sort of compound that has a bunch of C's in it. Yes, sir? Oh, you said bathroom?
Yeah.
I thought you said, could you go back?
Oh, okay,
Yeah,
no, no.
hurry. Yes, sir.
So is that why that like big show thing, that has OH?
Is an acid.
Is an acid.
Acetic acid. Yep. Chaku. Because it's got CH, CH,
Can you repeat why the H comes off? Or
Oh, the H, I haven't even actually gone to that. So the reason the H comes off by itself is because the electronegative density goes away from the H. And this O and the C have a very tight covalent bond. So the O doesn't want to break up.
But the H does.
The H has no choice because the H is weak and can't take any electrons with it.
Yeah.
So the H,
So, yeah. So the H is having a bad time with O, while O is having a good time with Y. Wait, hold on. That sounded weird out of
and
context.
so then the H leaves, yeah. Okay. Now guys, which one of these two is stronger as an acid? The one with just Y, or the one where Y has itself attached to two very electronegative O's?
The second one.
Why?
Because it draws more of the electrons away from the H.
Very good. And the less access H has to electrons, the easier it is to get the H to come off, okay? Oops. So, acid strength also increases as the electronegativity. So, if whatever's here, it could be a Cl, it could be a C. If the electronegativity on this side is bigger, the H comes off easier. Okay? So, the more electronegative the right side of the O is, the easier the H comes off.
So, the more electronegative Y is,
Whatever Y is, yeah.
then that
The
means
easier
it's,
H comes off.
then that
Stronger
means it's
acid.
stronger because Y is pulling more of the negative.
Right. Now, to be clear, guys, this doesn't necessarily make it a strong acid. It makes it a stronger acid. You guys kind of know the difference there? Like you don't have to be something. You don't have to be something to be the
Best.
version of it, the stronger version of it. Yeah. Yeah, exactly. You don't have to be best to be better. Okay.
Like you
So,
use that for life, you know?
as an example, guys, if it's an IBrCl, your acid strength is going to increase going this way because the electronegativity increases going up and what on the periodic table, guys? Up and right. And in this case, just up. All right. So, and then this is what we were just talking about earlier. If you add more O's to the end of it, that also increases the acid strength because you've got a more electronegativity on the other side away from the H. And that makes it easier for what to come off? The H. All right. So, carboxylic acid. Guys, who took AP Bio?
I did.
You guys remember COOH?
No.
COOH are called carboxylic acids. And so it's relatively easy for the H to come off because you've got all this electronegative density over here, this double bonded O and such. So R can be anything, guys. It could be a nitrogen compound. It could be big hydrocarbons. But the most important part of a carboxylic acid is the COOH, the COOH, COOH. And a lot of times you'll see it like this, something COOH or CO2H. Although I hardly ever see this one, it's almost always like this, COOH.
True.
And if you're ever asked to draw a Lewis structure of COOH, what do you need to remember? One of the O's is double bonded. Okay? Guys, I don't know if you remember this, but in organic stuff we don't collapse them very often like this. We usually have them kind of split off as we write the name or the formula to make it easier to see where things go. If you see COOH, you know C double bond O, OH. It's not going to be COOH, it's C double bond O, single bond O, single bond H. Yes, sir.
Can you explain why it's a weak acid?
Because it's not strong.
Thanks. This whole strong weak thing is so stupid.
So it's not going 100%.
Is that it?
That's it. All right, any other questions?
It's because it's not polar.
All right, so, oh no, it's very polar. That's why it's an acid to begin with.
Oh, true.
Are all acids and bases polar?
Yeah, they almost have to be, right?
Yeah.
Because otherwise there's no reason for the H to jump off or join something
Because
else.
then they can't dissociate into water, right?
Right, it's all kind of a, yeah.
And all oils are non-polar, right?
Yeah.
And so that's why whenever you mix a base and an oil, they make soap or a soap-like material.
It depends on the oil, especially if there's like O's and stuff for it to latch on.
I mean, like you said it in an earlier slide that it will wrap with the oils in your skin.
Right, yeah. Well, because what it does is it attacks a portion of it, and then it becomes a soap. Because soap's definition is it has non-polar chains and polar components.
Yeah.
The acid or base usually will provide the polar part of it, the polar head, or as you.
And the fact that it was a base is just, it's irrelevant. And the only part that matters is that it was polar.
Correct. The polarity allows it to be dissolved in water.
All right.
Hey, what's up?
Does this class have like a group chat or Discord?
Here you go, Madison.
I don't know.
No name.
Secret admirer.
Michael, go for this one.
All right.
Michael got one?
So, guys.
That is not the reaction.
So, guys,
Anybody
on
needs
the
something?
homework or on the
Okay,
AP
I'm
exam, on my test,
I can have
guys,
it.
if you're given two choices where everything looks the same except what do you notice about the R groups here? What's on this R group? C with H's. But what about this R group? Is that a fly?
It looked like a piece of dust.
Oh.